Hi everyone, just to give some overview of our presentation. So the title of our poster is The Investigation of Work Zone Crisis in New Jersey Using Support Vector Machine. I am Sajid, a graduate student at the Department of Civil and Environmental Engineering in Rowan University. So why is work zone important? Any crash which happens in work zone is termed as the work zone crash, and only in 2018, 671 people in the US died due to this, according to NETSA. And 34 crashes was in New Jersey in the last 5 years. So our objective is to assess the impacts of the contributing factors of work zone crash in New Jersey using the support vector machine. In our dataset, we had 13 fatal crashes, which means the death of the people. We had 254 crashes, and for property damage only, we had almost 8,000 crashes. So we took the data for 3 years in New Jersey from 2016 to 2018 from the NJDHDS. So for our method section, we collected the data from New Jersey version crash data, and we pre-processed the raw data and categorized them with level encoding. We had trained and tested using different ratios, and then we go through the CART, which means the classification regression tree, to get the important variables, and then we implemented the support vector machine algorithm. And then to the sensitivity analysis, we have seen what is the impact of the most contributing factors. Then we developed some countermeasures and seen through the model's accuracy. So for our dataset, we had like 20 different explanatory variables, which contains the temporal, like the season, the day of week, time of day, vehicle characteristics, the total vehicles involved, vehicle type. We had the rotor features, which is a bunch of parameters like number of lanes, temporary traffic control device, traffic controls present, speed limit, and functional class. We had the crash attributes, which had curve related and crash type. We had the environmental conditions, the surface, weather, night conditions, the driver's characteristics, the age, drug driver, distracted driver, and DUI. So the support vector machine, what it does is it separates the data in 2 or 3 different classes depending on the number of classes in a target variable. So we had 3, like fatal and injury and PDO. So they created 3 different planes to separate them. And the margin between them depends on how many support we have. So the points that we have in the boundary line is called the support vectors. From the analysis, we have seen that at the 75:25 ratio for the training and testing data set, we had almost 95% of accuracy, which is really good. At the same time, in the precision, we have seen for the PDO, the precision is pretty well, like 97%, but for the fatal and injury, the precision wasn't that much because of the high imbalance of the data set. From the sensitivity, before the sensitivity analysis, we have gone through the variable importance by CART, and we have seen that the parameters like the total vehicles involved, light conditions, alcohol involved, vehicle type, and speed limit, those are the parameters that had the most influence in the decision tree for splitting the, or acting as the primary splitter of the dataset. And we have gone through the 6 basic parameters which had the most influence on the dataset. And we have seen that the contribution of the crash type, the speed limit, alcohol involved, and total vehicle involved was the most in the severity prediction of the dataset. So from our finding, we have seen that the CART analysis have gone through these 6 different kinds of important variables. Our accuracy was 95%, and from the sensitivity analysis, we have seen that the speed limit and crash type had the most influence on the severity of the crash. And the countermeasures that can be developed is reducing the speed limit, improving lighting condition, and educating people regarding DUI. So that's all from our poster. If you have any question, you can reach us, and we have the links and everything on the O design. Thank you all for your patience hearing. Thank you.